There is a moment, engineers know it well, when ambition stops being a virtue and becomes something else entirely. These machines exist in that space. Not trucks in any sense you have imagined, not the kind you pass on a highway or see at a construction site. We are talking about machines that swallowed entire buildings in their shadow. Machines that required their own roads, their own fuel systems, their own teams of engineers just to survive a single shift. Some of them killed the men who built them. Some of them nearly destroyed the companies that dared to fund them. And at least one of them was quietly erased from the record. No press release, no museum, just gone, as if someone decided the world was better off not knowing it had ever existed. We will get to that one, but understand something first. Several of these machines were not engineering triumphs. They were engineering confessions, admissions that the humans behind them had crossed a line they did not fully understand. One of them required not one engine, not two, but a combination of power plants so extreme the drivetrain had to be reinvented from scratch. One was so dangerous, its operators developed a psychological shorthand for the moment things started going wrong, because by the time instrumentation confirmed the problem, it was already too late. One nearly bankrupted a manufacturer that had survived 2 world wars. One was so large it required its own permanent infrastructure just to move from one location to another. And the machine sitting at number 1, the one we're building toward right now, did not just redefine what a heavy-duty truck could be. It redefined what the word too big actually means for an entire industry. You will not believe it existed. The specs will not feel real, but they are. Let's start with number 5. Number 5, Volvo A60H. We begin with a machine that redefined the limits of agility in the heavy-duty world. While the massive rigid mining trucks we will see later rely on well-maintained haul roads, this beast was built to conquer terrain where no road exists. This is the Volvo A60H, introduced in 2016. It stands as the undisputed king of articulated dump trucks, a machine designed for the most extreme off-road environments imaginable. Before its release, the industry believed an articulated hauler of this magnitude was engineeringly impossible, but Volvo shattered that ceiling to meet the demands of operations that were simply too muddy, too steep, or too rough for rigid haulers. The A60H carries a payload of 60 tons, which is a massive leap over the industry standard 40-ton articulated trucks. It is powered by a 16-liter Volvo engine, generating 639 horsepower. With a gross operating weight exceeding 217,000 pounds, it is a significant step up from standard construction equipment. It serves the heavy quarry and open-cast mining industries, specifically in zones where rain, mud, and steep gradients would leave rigid trucks spinning their wheels. The engineering marvel here lies in its hydromechanical steering and active suspension. The tractor unit can twist independently from the trailer, allowing the wheels to maintain contact with the ground even when the terrain looks like the surface of Mars. However, the sheer size of the A60H created a unique problem. Its tires are so specialized and massive that they had to be developed specifically for this model. It is a master of terrain, a flexible giant that changed earth-moving logistics forever by allowing heavy hauling to continue during the worst weather. Yet, as impressive as this off-road warrior is, its payload capacity is merely a fraction of the rigid-frame titans that dominate the Ultra class. The A60H is big, but the next entry abandons agility for sheer, unadulterated capacity. Number 4. Komatsu 930E-5. Number 4 takes us into the realm of the ultra-class rigid haulers, where the primary goal is moving mountains one load at a time. This is the Komatsu 930E-5, a model that began rolling out around 2017. While it looks like a standard dump truck from a distance, standing next to it reveals a terrifying scale.
This machine is a staple in the copper and iron ore belts of the world, designed not just for size, but for a new era of digital integration and autonomy. This truck represents the transition from mechanical brute force to intelligent industrial robotics. The 930E-5 boasts a payload capacity of 320 tons. It is driven by a gargantuan diesel engine that acts as a generator, feeding power to massive electric traction motors in the wheels. This diesel-electric system produces a staggering 2,700 horsepower. With a gross vehicle weight of over 1.1 million pounds, this machine is heavier than a maximum capacity Airbus A380. What makes the 930E-5 extraordinary is its adoption of the front-runner autonomous haulage system. Many of these units operate without a human in the cab, guided by satellites and high-precision GPS to navigate complex mine sites with millimeter accuracy. A surprising engineering detail is the electric drive system's retarding capacity. Instead of using traditional friction brakes that would burn up under such massive loads, the electric motors reverse polarity to slow the truck down, generating enough resistance to halt over 1 million pounds of rolling steel on steep descent grades. This energy is dissipated through a massive grid of resistors that act like a giant toaster, blowing heat out of the truck to keep it under control. It is a technological marvel, but even this autonomous giant is about to be overshadowed by an American legend that decided to push the vertical limits of what a truck can be. Number 3. Caterpillar 798AC. Number 3 is the Caterpillar 798AC, a machine introduced in 2019 that signaled a massive shift for the world's most famous heavy equipment manufacturer. For decades, Caterpillar relied on mechanical drive systems, arguing that a drive shaft was better than electric wires. But the 798AC embraced electric drive technology to move more dirt with greater efficiency. This truck is a towering skyscraper on wheels, designed to dominate the Canadian oil sands and Australian coal fields. It represents the pinnacle of American industrial design, prioritizing operator comfort despite sitting 3 stories in the air. The specifications are staggering. The 798AC offers a payload of 410 tons. It is powered by the CAT C175-16 engine, a 16-cylinder power plant that churns out 3,500 horsepower. The total operating weight pushes past 1.3 million pounds. The sheer height of this machine is difficult to comprehend. The driver sits nearly 22 feet off the ground, requiring a diagonal stairway just to reach the cab. From that height, a standard pickup truck parked next to the tires looks like a matchbox. The radiator grille alone is larger than most garage doors. The engineering brilliance of the 798AC is found in its integration of the braking and drive systems. The retarding grid, the system that dissipates the heat from braking, is so powerful it can generate 5,400 horsepower of resistance, allowing the truck to descend mountains fully loaded without touching the service brakes. The tires alone are over 13 feet tall, costing more than most luxury cars apiece. This machine is a testament to the pursuit of payload, yet there's a German competitor that manages to pack even more power into a lighter frame. The CAT 798AC is heavy, but our runner-up is the definition of power density. Number 2. Liebherr T284. Number 2 is the Liebherr T284. Introduced in 2012 and refined over the last decade, this machine is often cited as the lightest ultra-class truck relative to its payload, earning it the title of the Efficiency King. Built in Newport but engineered with German precision, the T284 is designed to spend less time in the shop and more time hauling gold, copper, and coal. It's a masterclass in weight distribution and structural integrity, proving that you don't need to be the heaviest machine to be the strongest. This white giant carries a payload of 400 metric tons, rivaling the largest machines in history. However, it takes the lead in brute force with an engine option that delivers up to 4,000 horsepower. That's the equivalent of 4 Bugatti Veyrons bolted together. The gross vehicle weight tops out at 661 tons. The T-284 serves the most demanding high-altitude mines in the world, where thin air usually strangles engine performance. The massive engine bay is designed to accommodate the largest industrial engines on the market, specifically the MTU 2400, ensuring it maintains speed on grade, even when fully loaded. The surprising engineering detail here is the Litronic Plus drive system. It utilizes high-speed processing to adjust torque to individual wheels instantly. This means if one tire slips on ice or loose rock, the computer redirects power to the others in milliseconds, maintaining traction where other trucks would slide. It's the ultimate combination of brains and brawn, allowing it to accelerate faster than its competitors. But even with its 4,000 horsepower, it's not the world record holder. The next machine is so large, it technically shouldn't exist. Everything you have seen so far is conventional. Number 1 is an anomaly. Number 1. BelAZ 75710. Number 1 is the BelAZ 75710, introduced by the Belarusian manufacturer BelAZ in 2013. This is not just a truck, it's a rolling monument to industrial excess. It was built with a singular goal, to haul more earth than any vehicle in human history. It currently holds the Guinness World Record for the largest haul truck ever built, a title it has defended against all challengers for more than a decade. When this machine arrives at a mine, the site managers often have to widen the roads and reinforce the bridges because standard infrastructure simply collapses under its bulk.
The statistics are nearly impossible to believe. The BelAZ 75710 has a payload capacity of 496 tons. To move this mass, engineers realized one engine was not enough. Instead, they installed two 16-cylinder diesel engines, generating a combined output of 4,600 horsepower. The fully loaded weight of this Leviathan is over 1.8 million pounds. It is as heavy as 60 African elephants standing on each other's shoulders. It is so wide that it occupies the width of 3 highway lanes. The engineering solution required to make this work was unprecedented. Standard mining trucks have 6 tires, 2 in the front, 4 in the back. The BelAZ 75710 has 8 massive tires, with 4 on each axle. This dual-axle steering system allows the truck to have a turning radius similar to machines half its size, despite being as wide as a gymnasium. Furthermore, when the truck is not carrying a load, it shuts down one of its 2 engines to save fuel, running on economy mode, before roaring back to full 4,600 horsepower capacity for the haul. It is the apex predator of the mining world, a machine that redefines the very word heavy and stands alone at the top of the food chain. From the agile articulation of the Volvo to the record-shattering scale of the BelAZ, these machines prove that humanity's obsession with scale knows no bounds. We continue to build bigger, heavier, and more powerful iron giants to harvest the resources beneath our feet. Which of these industrial monsters shocked you the most? Was it the autonomous intelligence of the Komatsu or the sheer double-engine brute force of the BelAZ? Let us know in the comments below. If you enjoyed this deep dive into heavy metal, make sure to subscribe and hit the bell so you don't miss our next tour of the world's biggest machines. Keep building and keep it heavy.